In this final video on nuclear science applications, we're going to look at how it's used in technology, from something as simple as a smoke detector in your home to how we use it in satellites that explore the outer reaches of the solar system.
Let's take a look at two extremes of technological impacts of nuclear science, one found in almost every home and the other hundreds of millions of miles away. The first example we're going to look at are smoke detectors. These are small devices fitted across several locations in your home that sound an alarm when they detect smoke from a fire. They work by using a small amount of americium-241, a synthetic element that decays via alpha emission. Remember that alpha particles are positively charged, so when they collide with a detector plate, they induce an electrical current. In the event of subparticles in smoke crossing the path of these alpha particles, they are absorbed and thus don't reach the detector, stopping the current and triggering the alarm, alerting occupants that there may be a fire. Although it's often a false alarm when you're cooking, this seemingly trivial piece of plastic stuck to your ceiling saves lives, so remember to test it at least once a month, and if you don't have one, invest in one. A somewhat more exotic use of nuclear science is as a power source for satellites designed to study the outer reaches of the solar system. Satellites orbiting the Earth generally are fitted with large solar panels which capture light from the sun and convert it into electricity which powers the technology on board. If, however, you wish to study planets and moons far away from the sun, where light intensity is insufficient for this to work, some satellites are fitted with sources of plutonium-238. The heat given out from its alpha decay, sufficient to make it glow red, is used as a power source on board. An example of a satellite employing this technology is Cassini, launched by NASA and the ESA in 1997, which is fitted with around 33 kilograms of plutonium, sufficient for it to have accomplished its mission to study Saturn and its moons and rings. This concludes this part of the series on applications on nuclear science. Next, we will begin to look at one of the most controversial issues surrounding nuclear energy, and that is nuclear waste, before finally talking about how we quantify radiation and give an indication of how much is safe.